inconvenience cultures.
Okay. Yeah.
Okay, thank you very much for my time. And good morning, everybody.
Morning.
Morning.
Everybody come from Indonesia? I think just one will not come from Indonesia.
I'm from Taiwan.
Okay, right now I'll try to present my previous work in our lab 3, actually in our study. And right now my study focuses on bioethanol production. And I chose this due to development of high productivity ethanol production using VVA, mobilized mononas mobilis in continuous culture or in continuous fermentation. And right now I study in National Cheng Kung University. Okay, in my first introduction, I will let everybody know if why I chose bioethanol as my study. Because everybody know right now bioethanol should be as an alternative energy. And it's the most promising, I think, it's the most promising, and it could be due to fossil fuel depletion. But in here, I try to develop based on bioethanol approach, and I use. Actually, we have many strains like strictly anaerob, like Clostridium sp, and also we have like well-known Saccharomyces cerevisiae, or well-known yeast in the world, I think everybody know. But right now I use facultative anaerob, that is Zemomonas mobilis. Why I choose this strain? Because Zemomonas mobilis is produce less ATP and also less biomass, so it's corresponding to high productivity of soluble metabolism like such ethanol. And this is a comparison of a operating model which I use. In my previous work, I used a best fermentation, but right now I use continuous fermentation. And you can see why we choose continuous fermentation, because in batch fermentation, the productivity is very low. I think lower than continuous fermentation. And also, if we talk about price, the price for batch fermentation is very high, or higher than continuous fermentation, because it's due to lack path of microorganism cell growth. So I think the continuous mode is preferable to use. And then also for continuous fermentation, the operation is very easy to control. Once this process achieves the steady state, so we can reduce the labor cost, I think, and also we can very easy to operate this operation. And also in my study, I use cell immobilization. Because if you compare to suspended cell or free cell, this kind of modification could be very high in yield, and also it's very good in stability, because the cell entrapped inside gel, and in here we use PVA polyphenol alcohol as a polymer, and also it's very possible to generation. Actually, for suspended cell or for free cell, also possible for generation, but we need some additional equipment or devices like maybe membrane or ultrafiltration. But in here, we don't need the additional equipment. We can just operate in one single stage fermenter. But besides FNT, also cell immobilization have some disadvantage like low mass transfer, because everybody know the cell entrapped inside the gel or inside the polymer, so it's make mass transfer could be a little bit difficult. It's material and method. And in here I choose Zemomonas mobilis ATCC 29191, and this is a medium for fermentation. Actually, I use for culture medium is extract about 10 grams per liter, but for my fermentation medium I use 10-fold dilution. Yeah, there is 1 gram per liter of yeast extract, and also it's contain phosphate over 0.01 molar, corresponding to pH 7. And in my study, I use 14 volume 200 milliliter. by using my self-designed fermenter, and also HLP is 7, but it's not controlled for operation. Also, I just employ this fermenter in room temperature. So I think it's very low cost for this production. And this is my method for preparation. The Zimobilis broth, harvested Zimobilis broth, just centrifuge first, and then we suspend it with an ACL to make it easy mix with PVA gel. And then after we finish to mix sulfur plus PVA, and then we set up the experiment, just pass the palm to be and drop it in the buffer. In here we use boric acid buffer. And then this is my experimental design and fresh medium. In my previous work I just used glucose as a salt carbon source, but right now I use the others. And this is my fermenters, only 200 working volume of cell-designed fermenter. And finally, I just connect this experiment to gas meter to measure the CO2 production. And my analytical assay, I just use SPLC for soluble metabolites like ethanol, glucose, and the others soluble metabolites, and also TC for CO2 production. This is my result and discussion. First, I want to investigate the effect of glucose loading on the stability of continuous culture of immobilized cells, Monas mobilis. And in here, you can see the most stable one is the 100 gram per liter of glucose loading. You can see for 20 gram per liter of glucose loading, the trend should be decreased for every 5 days, I think. For every 5 days, and it's not stable for more than one month. But in here, after 20 days, you can see the ethanol production should be decreased, but it's not very significant, I think. So this is the conclusion. You can see for after 24 hours, the ethanol production for 20 gram per liter only 8.0906% gram per liter of ethanol production, but with the ethanol yield just around 81% for theoretical yields. But for 100 gram per liter, you can see we can get 92% of theoretical yield. For residual glucose, you can see even for 20 gram per liter of initial glucose, we can get 100% of glucose conversion, but it's not guaranteed this ethanol production will be the optimal condition, because I think for this case, the growth cells, the substrate or the carbon source for cell growth is might not sufficient, so it could be reduce the ethanol production in the future. And you can see and the second one, I try to investigate the effect of cell loading on ethanol production and productivity. So I try to vary 20% weight per volume, and then 40%, and then 50%. And in here, we choose the optimum one is 40% weight per volume, with the ethanol concentration 48.31 gram per liter and productivity 16.10 gram per liter per hour. Actually, normally for more higher cell loading, it could be produce more ethanol, but in here we have some problem, because when we try to load more cell, the cell tend to stick each other. That makes mass transfer is a little bit difficult. So we choose 40% as an optimum value. And here I try to investigate effect of HRT or dilution rate on ethanol production and productivity. I choose for 1 hour, 2 hours, 3 hours, and 4 hours of HRT. And in here, you can see the optimum condition should be at 4 hours of HRT. But we still can consider the 3 hours, because the residual glucose is only, if I'm not wrong, 6.05 gram per liter. But due to the cost issue, because the glucose a little bit expensive, So in here, we choose the 4 hours of HRT as the optimum condition with the total ethanol production 49.89 gram per liter and ethanol productivity 12.47 gram per liter per hour. And after we got both cell loading, the optimal cell loading, and also the optimal HRT, I tried to increase the glucose concentration, initial glucose loading, for 100 gram per liter to be 125 gram per liter and 150 gram per liter. And in here, because in here we first we consider the ethanol productivity, and the second we consider the residual glucose. So I chose 125 gram per liter of initial glucose loading as the optimum condition, with the ethanol production about 62.97 gram per liter and the ethanol productivity around 15.74 gram per liter per hour. I think it should be good enough for the ethanol productivity. But actually, we also can consider the 150 gram per liter of initial loading, because the residual glucose only is 8 gram per liter. So maybe we just need some improvement to overcome this problem. And in here, I just want to try to compare my study with the other study, literature study I made. And this is my previous study before. I also used this strain with CSTR or petty mode, but I just used glucose loading 50 gram per liter. But the ethanol productivity is still very low, only 3.2 gram per liter per hour, with glucose conversion only 65%. But right now, I try to employ 100 gram per liter, 125 gram per liter, and 150 gram per liter. But in here I can find the better value of ethanol both ethanol productivity, also ethanol production. And the most important thing is glucose conversion is almost complete. There is 100%. So, in my conclusion, I think this study should be considered was successfully carried out with high sugar loading until 150 gram per liter with ethanol production 79 gram per liter. And then if we see the advantage of this modification, this modification can overcome both substrate inhibition and also product inhibition. And then if we consider for stability of fermenter or stability of strain that we use, 100 gram per liter of glucose loading should be the optimum condition. And it can maintain until 1 month of operation. And then if we consider the cell loading, 40% weight per volume was selected as optimum condition also, because it's able to increase the fermentation rate if you compare to 20% weight per volume. And 50% weight per volume is unnecessary, I think. And if we consider the dilution rate or hydraulic rotation time, 4 hours should be considered as favorable with the ethanol titer, ethanol productivity, and residual glucose concentration. We got 49.89 gram per liter, and then productivity 12.47 gram per liter per hour, and the residual glucose only 2.04 gram per liter. And in summary, after I tried to increase the initial glucose loading, and I got best ethanol productivity with the complete glucose consumption at initial loading 125 gram per liter, with the productivity 15.74 gram per liter per hour, and cell loading only 40% weight per volume, and dilution rate only 0.25 H. And I think this is my reference when I do this study. And thank you for everybody for listening, and I hand over to moderator for discussion section. Thank you.
Such a great presentation. Yeah, and nice topic.
I hope.
Yeah. Any question? No one? This is very interesting, I think, because the time is to share each other. We correlate with the application of ethanol.
Yes, bioethanol production.
Okay.
Yes.
Could you mention your name and where are you from?
My name is Dewa Zakaria from Bogor Agricultural University. Good morning, Mr. Hayati.
Good morning.
Well, how we applied your experiment in your laboratory to use in real industry?
Actually, this is my preliminary study. This is my previous work in my study, just a part of my study. But right now, I try to employ with lignocellulose sequence like Bagas, Prestro, and the others. And also, I try to modification with some integration with VME, vacuum membrane distillation to got the ethanol, the pure ethanol product. So I think it's very usable in application, in industrial application at least. Because, yeah, I just want to let everybody know. This is very promising for us, and later we can do some modification, I think.
Any other question? Any other question? Okay. Thank you very much. Let me summarize. This Mrs. Nur Hayati already success to enhance the ethanol productivity using the continuous fermentation. Am I right?
Yes.
Yes. And I hope this will be applied in the future.
Yes.
Okay, thank you. I will welcome for the next speaker, Nizar Amir, with title IT Quality System.
To present my previous study about the intermediate temperature proton solid oxide fuel cell and nickel turbine hybrid system fueled by methane mixed biofuel. And then I have a master student for the Chongyang Tashi, and then this is my professor, but not come here. And for introduction, now I have some many big problems about the increasing greenhouse gases, and then methane is one of the greenhouse gases to make some global warming. So our effort to decrease the methane consumption in the power electrical consumption in the world. So we use the AISCT, because AISCT is considered about the favorable renewable fuel because it can be produced from oleic acid, and also can produce the high hydrogen production from the forming process. This is the solid oxide fuel cell. Fuel cell now considered to be the best promising green technology for direct chemical into electrical energy conversion, And then, but the fuel cell have many types, but the solid oxide fuel cell have an attractive characteristic because they offer high efficiency, low pollutant, and also the many potential applications. However, ordinary solid oxide fuel cell, I said ordinary because we use oxide through the electrolyte, so use ordinary, requires high temperature. In high temperature requires high cost production. So we want to reduce the cost production, and also for smaller scale application, there is a trend to change the lower operation. It means proton solid oxide fuel cell. So we change to oxide to proton because we want to reduce cost production and also increase the efficiency. This is the proton solid oxide fuel cell. Solid oxide fuel cell, based on the proton conducting electrolyte, has been considered the preferred fuel cell technology. In the proton, high hydrogen partial pressure in the anode side can be achieved because steam production in the cathode compartment. So no dilution of a hydrogen gas in the anode compartment. The result increase the open voltage and also the enhanced power solid oxide fuel cell. This is my system configuration in hybrid system. We use the software to simulate the thermodynamic analysis. We use MATLAB for more deeper discussion. We use the Simulink, and also for deeper again, we use the Thermolit, more detail about the discussion of a hybrid system. First, compressed air and also the fuel preheated in the characteristic reformer and also heat exchanger to increase the temperature before entering the stack. And then in the stack, the electrochemical reaction occurs in the stack compartment to produce electric power. Because in the fuel cell, not 100% of fuel can be converted to electric, so maybe have some unreacted fuel, so we use a combustion chamber to burn, to increase the temperature to use in the microgas turbine, to increase the power output. And also we use two different reforming process. First, steam reforming for methane and autothermal reforming for isooctane, because isooctane needs higher temperature in the steam reforming, so we change the reforming type to autothermal reforming. And next, my result of discussion. In this study, I used T atm of pressure and 0.85 of fuel utilization and 2.2 for steam carbon ratio for methane steam reforming. In this system, we will investigate where methane is partially replaced by biofuel until 50%. For result discussion, we show you about the electric current and also the power output. Increase the biofuel concentration until 40 will increase the electric current and also the power output. But unfortunately, after 40% to 50%, the electric current and also the power output is decreased. And also the increasing biofuel concentration until 40%, the hydrogen mole fraction increase significantly. But after 40% to 50%, the hydrogen production is decreased. Because increasing biofuel concentration, more chemical energy can be converted to hydrogen. Hydrogen production increase until 40% and then decrease. Because decreasing of methane percent replaced by biofuel. Even biofuel can produce the high hydrogen concentration, but need high temperature to fulfill the reformer requirement. At the first, increased biofuel concentration will increase the hydrogen mole fraction, but after that decrease because because biofuel need high temperature to fulfill the steam the autothermal reforming. So in the intermediate temperature, the temperature is not too high, so that's why the hydrogen production is decreased. And also we discussed about the TIT, turbine net temperature, and also the power output of turbine. Increasing the biofuel concentration, TIT and also the power output of turbine is increased significantly. In intermediate temperature, reformer cannot convert perfectly of fuel because to hydrogen, because more unreacted fuel such as biofuel, CO, and also the hydrogen to burn in the combustion chamber to increase the TIT. TIT is have some linear about the turbine power output, so increasing TIT and also increasing the turbine power output. This is the unreacted fuel from the stack. Increased biofuel will increase the unreacted fuel significantly. Unfortunately, the system efficiency is decreasing with increasing biofuel concentration. But in this session, it's enough to fulfill the decreasing of exhaust gas from the stack. Almost the system efficiency decreasing, but the exhaust gas about the about the CO concentration and also the CO2 is decreasing with the increasing biofuel concentration. Although the power stack and also the microgas turbine increase significantly, however, efficiency decreased gradually because many chemical energy from the fuel cannot be converted perfectly into hydrogen. Use the stack in the intermediate temperature. And this is my conclusion. First, power stack increasing with increasing of biofuel concentration until 40 and then decrease. But for TIT and gas turbine, increasing with increasing biofuel. Unfortunately, the system efficiency decreasing with decreasing biofuel concentration. And then, because this is my previously very far about my study now, Mr. Jason need new design configuration to improve the system efficiency and also improve the proton stack configuration. But this suggestion has been complete. I have solved this problem, And now in my study now, I can increase the stack efficiency until 40% and also the power until 60% and the CSP until 90%. So this is the problem. I can solve the problem, and for the now study, I can increase efficiency very high because I have a new design for the hybrid system, and also I can design more efficient about the stack configuration. Thank you.
I like the topic. Yes, because my topic is about lithium-ion battery. I think it's more connected with the person. Okay, any question? No one? Okay, please introduce your name.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siswi Arya from Bogor Agricultural University. I just want to ask the simple question. Do you agree if animal waste is the big producer for methane? And it's like that. Thank you.
Producing methane many in the world, such as in the volcano and also the animal waste and also the many things. But I'm not 100% agree about the from animal waste because there was some. I think it's the most problem now is for the electrical company. You know, use in the United States almost producing hydrogen from methane. So that's why we want to decrease the methane consumption with the biofuel. And also before, like ethanol is good for the hydrogen production, but need high temperature to fulfill the steam reforming requirement. But now we change to dimethyl ether and also the isooctane, and also the methane is good for the hydrogen production.
Thank you, sir.
Any other question? Any other question? May I ask the question? Okay. In the earlier slide, I see about the simulating. You do this experimentally or using the software? Or you combine the software?
Just for the first time, I use the software.
Oh,
But now I have some
experimental.
completely my compartment in the lab. So as you know, I use maybe I want more detail about the material, and because this is the ordinary solid fuel cell, use oxide through the in this side oxide react with the hydrogen, produce water in the anode side. So the hydrogen production in the anode side can be diluted by water. So it means the pressure of hydrogen decreasing. But now, in the first time, I simulate in the Simulink and also the Thermolink for the stack. But the result is increasing of efficiency. So my professor asked me to make some compartment in the real life. But now we cannot compare with the simulation in the real life in the same result. But in the real life, I can produce maybe only 25% of stack efficiency. But in the Simulink, for the theoretical study, we can produce until 40%. Because it's
Yes. Can I ask another question? Okay, because I rather know about you said that this includes for the electrochemical reaction. You know which part of electrochemical reaction here? Can you show me about the electrochemical?
the electrochemical reaction in here. Because in the proton, which one do you like, proton or oxide? Proton. In the hydrogen production, we offset to proton and the electron. This is the electrochemical reaction in the cathode. You know, in the cathode we have some activation losses. We decrease the activation losses because activation losses decreasing the electrochemical reaction. So that's why we use a good material to increase the electrochemical reaction in the anode side. This is the more important electrochemical reaction in the anode side. Because in the anode side, for the frozen solid oxide fuel cell, the high pressure of a hydrogen can be achieved better than in the oxide solid oxide fuel cell.
Any other question? Okay. Yes.
Thank you very much.
Thank you very much. In Indonesia, rural areas to support domestic energy endurance. Please welcome Mr. Budi Wakiman. Oh, one thing.
Ya, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone.
Good morning.
How are you today? I hope all of us feel good today, alright? Okay, thanks for the chance so we can stand here to present our idea about integrating strategy of bioethanol industry based on animal waste biomass to livestock business on Indonesia rural areas to support domestic energy endurance. Please, first of all, I want to introduce our team. My name is Isfi Arindia and my partner is Budi Wardiman, and next Muhammad Afif Azhar. We come from Bogor Agricultural University. Okay, next. Okay, as we know, Indonesia is one of the developed country in the world. So, as a consequence, Indonesia have to try to always improve the economic activity in every area sector, right? And in other hand, growth population is also also continuously increased rapidly every year. Growth population and economic activity development is very influenced to the nation energy consumption. Nation biofuel consumption increase is about 3.48% every year. Meanwhile, production of national biofuel decreased continuously every year, about 2.16% every year. So what's the current energy problem in Indonesia? Many areas in Indonesia are not covered yet by energy distribution network caused by isolate and high freight charge, especially in rural areas. So what we should do to solve the problem? One of the ways we can explore the rural potential to support their own energy requirements. And as we know, Indonesia has abundant biomass. For example, is biomass which produced by animal waste. Animal manure can be converted to bioethanol. So that's why we need to integrating bioethanol industry to agribusiness livestock in Indonesia rural area. Thus, effort to integration of bioethanol industry is expected to have a positive impact, such as the building blocks to build a solid national energy security, and then empower and develop infrastructure in the village, such as economy and social life. Villagers are able to fulfill their own energy requirements, and last, can reduce dependence on fossil fuels and reduce gas emission from livestock waste. Maybe that is our background how we choose this topic. Okay, and then I will give the opportunity, the chance to my partner to explain the main of our material. Please welcome Mr. Budi Wardiman.
Thank you so much for the opportunity that which given to me. Okay, I would like to explain you about the current energy condition in Indonesia. As we know that Indonesia population in the future will be continuous increase year by year. This thing will be contribute a positive impact for our economic activity development, but also give a negative impact for our energy availability in our country. In the graphic, we know that the graphic show that Indonesia population in 2000 increased 205 million and increased to 23.4 in 2009, or increased by an average 1.48% per year. Population growth will also impact to the growth rate of the hikers. We assume that to increase up to growth rates of the hikers is assumed to increase up to a certain level, and in 2030, the national average number of hikers per capita will reach a saturation that is similar to that of Jakarta in 2010, is 0.022 vehicles per capita. Okay, this is the graphic of gross domestic product and energy consumption. This graphic shows that energy consumption always larger than GDP. Historically, the Indonesian GDP from 2000 until 2009 continues to increase, while at the same auto consumption showed an increasing trend. It's grow sometimes up and sometimes down. This shows that Indonesia's economic growth is not always influenced energy consumption. As a consequence, the intensity of energy in Indonesia is less influenced by GDP growth. Okay, this is the potential of fossil energy resource. This source will continuous decrease year by year. Okay, this is the sectoral final energy consumption. During 2000 until 2009, energy consumption increased from 709.1 million BOE or barrel oil equivalent in 2000 to 865.4 million in 2009, or increase an average of 2.2% per year. The graph shows that the largest sectoral energy consumer is the industry sector, followed by the household and transportation sector. In 2009, the SEC accounted for 35% and transport sector reached 3 to 4% of the total energy consumption. Energy consumption in the household sector still use a lot of biomass in the form of firewood. Okay, the next I want to explain about the current renewable energy condition. We know that the current problem, the current energy problem that facing in Indonesia is a scarcity source in many areas potential in Indonesia. So our government has been doing everything to solve the problem. For example, find the renewable energy with the continuous available raw material of renewable energy. This is the list of bioethanol producer with the total capacity 388,000 liters per day. the nation bioethanol production target of 1% in 2010, which amounted to 240.541 kiloliters per year. It's difficult to achieve. Why? Because the raw materials that we are the source of the raw food and food, such as corn, cassava, corn, and molasses and palu. The raw material is very expensive, which about 70% of the cost of bioethanol production. In addition, the availability is very little because it competes with needs of humans and livestock. So this is the table that shows that biomass potential from animal manure in Indonesia. Every day, livestock produce about 160 million kilogram per day. So this is the potential that we can use to convert to bioethanol. Okay, the next I want to give opportunity for my friend to explain the next material.
Okay, thank you for this stage. I will show the SWOT analysis. Yeah, this is the strength bioethanol as renewable energy, and then the availability of abundant waste, land, and technology, and then availability of rural human resources, and then bioethanol is more efficient than fossil energy, and then support from government, and the weakness, the lack of development funds, and then freight transportation cost is expensive in Indonesia, and then the lack of use of bioethanol, socialization on rural area, and no exact price for bioethanol. And then the opportunities, bioethanol company has not been widely available on Indonesia. Okay, and then the trade, competition in the sale of bioethanol and competition for raw materials. And from this analysis, we make some strategies. Okay, next. Strategy number 1. There are farms development strategy. We build and develop livestock in the rural area. And then the strategy number 2, about bioethanol industry in rural development. And then the strategy of number 3, demanding government policies that support this strategy. Okay, I will explain the strategy number 1. Strategy number 1, we are focused on the formation and development of the farmer cooperative. And then we providing capital for the farmers. And then we give the controlling the farm environment. And then provision of facility and good infrastructure for the livestock. Okay, yeah, that is the diagram. Okay, and then the strategy of number 2. Okay, we give the main beneficiaries are the people in the rural area. This is for the poor person, so they can fulfill their needs. And then raw materials are not fully processed into bioethanol, but some raw material for the production of biogas and fertilizer. And then we develop micro business, until the macro business, gradually. Okay, and then the strategy of number 3, we can make the good condition in the rural area, so we can attract the investor, and then we can empowering the scholar to contribute in the rural area. Okay, so the conclusion is bioethanol industry development in rural areas is a strategic effort to promote and support energy security. In addition, through this effort, also improving rural infrastructure in all areas through the development of energy and empowerment is one of the targets. There are working main strategies that can be done in the development of this industry, namely farm and rural development strategy, bioethanol industry in rural development, and support local government through decentralization policy. Okay, thank you for your attention.
Special thanks to Allah SWT, our parents, our sponsor, that is Dompet Bapak and Elanco, and of course our lecturer in Faculty of Animal Science, Bogor Agricultural University, who had to support us in this paper. Maybe thank you very much for your attention. Sorry for our mistake.
Thank you for sharing. Okay, any question?
I have a question on the suggestion.
Please, the red pill. Mr. Hayati first. Okay.
Okay.
Tengisha.
Okay. My question is it still return to study or already doing your laboratory or not?
We get the information from the literature.
Oh, so it's still introductory review, right?
Yes.
Oh, so what are your plan for the future? Maybe you wanna try carry out in lab or pilot plant or?
In Indonesia, using animal waste to bioethanol production is not popular yet. So we want to begin to promote this strategy for the next step that the government can use.
The other question?
Because this is on the review, like article review. Maybe for the statistic, please you do not use from UTP. Maybe you can use from BP website, because more update for statistic energy in the world. Because I look only to 90. Where is the statistic? The year is 209. No. Especially, it's 2009. But in the BP, maybe it was 2012. It's more detailed about it.
Thank you.
Any other comment, question, suggestion? The export one can, really do bioethanol with Mrs. Nurhayati. Maybe all of you can ask me anything about. Can get anything to do. Okay. Please.
Okay, thank you for a chance. Before I explain my paper, I would like to introduce myself. My name is Yanto Hadianto from Department of Nutrition Science and Biotechnology, Faculty of Animal Science, Bogor Agricultural University. And my paper, the title is Waste Bamboo as a Potential Biomass Bracket, a Renewable Energy Source that Environment Friendly to use in both rural and modern areas. And this introduction, non-renewable energy has an important role for living people every day. And then world face energy crisis. It's thought that energy consumption has reached a high enough level due to increasing human population. The report saw rise in oil prices from 23 till 28 interpreted as a structural phenomenon indicating increasing fundamental shortage on oil reserves or signaling scarcity. Therefore, it needs saving action of energy using or find alternative energy source. Some alternative energy source like bioethanol, biogas, biodiesel, and biobriquettes. And then biomass bracket is one option. This is also can assist in the elevation of another problem in urban area like waste disposal. Why biomass briquette? Because biomass briquette have several advantage. We can see that briquettes are cheaper than coal, oil, or lignite once used cannot be replaced. There is no sulfur in briquettes. There is no fire ash. Consistent quality, have high burning efficiency, and are ideally sized for complete combustion. Combustion is more uniform compared to coal. Unlike coal, lignite or oil, briquettes are produced from renewable source of energy biomass. Loading and unloading and transportation are much less and storage requirement is drastically reduced than other renewable and other oil and other energy. Briquettes are plain to handle and can be packed in bags for ease of handling and storage. Briquettes are usually produced near the consumption center and supplies do not depend on erratic transport from long distance. Okay, I skip that. And then the factors that affect the quality of briquette were investigated, which are compaction pressure, compaction temperature, ratio of air waste to binder, and then the moisture content of constituent and particles of the air waste. In addition to this factor, there is a standard that is often used a comparison in produce of briquette waste, which is Japanese, UK, and commercial substance. Okay, like that. And the blowing chart of producing biomass briquette. The step one is preparation material and tools. The materials which used in its production is waste bamboo, including bunch and root, and then water and adhesive, and the tools is mold bracket and the testing tools, and step 2 carbonation. But before we are going to carbonation, we have to reduce the particle size to small size, and then dry below the sunrise to make efficiency of carbonation, and step 3 screening to get the high uniformity of the waste bamboo, and drying again. But this step can be skipped if you feel is enough. And then briquetting is mixed bracket and adhesive. The adhesive is handmade from starch or commercial adhesive and rice maybe, and the adhesive is 10% of the total mixing. And the next step is testing, packing, and then the product. Okay, the raw material. The raw material in this production is bamboo. Why I choose the bamboo? Because in my country, the main raw material of biomass briquette is coconut shell. But I want to make this raw material bamboo to be the one of the raw material to be used in biomass briquette. And here is a chemical component, and we look the lignin component is high enough, and then the lignin can make a bit little sorry lignin content can make effect to the value heat production. The higher lignin a bit little make the higher heat production. Okay. Why I compare? I already said because the coconut is the main raw material in my country, and then characteristic of bamboo in fixed carbon between two raw material is not much different, but in other component the coconut shell is slightly better than bamboo. But we look the S component. The component of coconut shell S is higher than rose bamboo, and we know the S is interpreted unorganic in the biomass, and the S role to lower quality of fuel. So from these facts, the bamboo can have a chance to be a raw material to be a biomass briquette. And here is a product of biomass briquette from bamboo in Thailand. In Thailand, the West bamboo is already industry. Okay, we can look there. And then the comparison of biomass briquette between bracket and the other fuel. We can look the bracket have several strengths than other fuel, like no pollution, moisture is smaller and can help to the burning, easy burning, and the cost is smaller too. The efficiency of burner good enough, and then the other comparison, we can look from labor usage, single person is enough, and boiler efficiency, normal fly ash, deposit on tube, and handling easy because of packet material. Okay, this is environment effect. Creating briquettes from bamboo waste can reduce the impact to environment of waste, improve waste management, and not detrimental to health. There are many byproducts from fuel, from coal, have a negative impact, but in this product, the sulfur content is the fuel of product is not traceable and therefore poses no problem. And then this technology is smokeless, without much smoke during ignition and burning, odorless, because contains minimum evaporative substance, thus eliminating the possibility of odor, sparkless, less crack, and better strength, help burn for a longer time. And this is advantage of this production. Development of charcoal briquette made of bamboo waste can be contribute more to the community, modern and rural area. For rural area, this technology can prove to be one among the solutions for supplementing the fuel requirement and socio-economic development by providing employment to rural people support rural economies, can help unemployed people, farmers, rural enterprises, and can be used as fuel in rural homes for cooking, laundering, and boiler in diesel. For modern area, there is an increase in economic benefit to the byproduct of bamboo craftsmen and scale up from home industry to bigger industry. And this advantage, burning of briquette can produce nitrogen oxide and carbon monoxide, but in a small amount. Availability of waste bamboo is also not higher than other biomass like coconut shell, wood, sawdust, rice husk, and newspaper waste. Every country have a different biomass availability, so for developing this technology depend on biomass availability of each country. And the last, the conclusion is producing biomass briquette from bamboo waste as an alternative energy source so prospectively. Chemical content is not much different from coconut shell. Briquettes are usually a mined raw material. Long-lasting flame and environment-friendly because smokeless, less crack and better strength. And economic value because its use has not been utilized optimally. And then biomass briquette from waste bamboo can use in both rural and modern area for many years. Okay, thanks for attention. And special thanks to Allah Subhanahu wa Ta'ala, my friend, and other contributors.
Thank you for sharing. Any question, comment, suggestion? Okay, Miss Hirayati.
Oh, maybe first question, I think would be say, visit the gender field.
Yes.
And then about because I see you just consider about the environmental effect, right? How about the cost effect? Did you consider it? Like because you use like carbonation 150 degrees C is very expensive, I think. I agree because you use waste bamboo, it's very cheap, but I disagree with the process. I think it could be more expensive. So did you consider the cost effect?
I already not considered that effect because I think carbonation need small cost. Because I don't know differ of carbonation cost maybe.
Because the temperature is too high, I think. Yeah. And also for your literary friends, for example, you use for bamboo characteristic in your step, you use from in Ganes blah 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 blah. Okay. But you wanna try your bamboo in Indonesia, so actually you cannot compare this in their area in our area. It could be very different. Okay. And also maybe you have to consider about maybe this just suggestion. Okay. About the time. Because you use for a long time, like I see 1957, the year of literary friends. It should be upgrade, the upgrade one.
Okay, thank you for advice.
Any suggestion? Please give applause. There's the newcomer, Mr. Dick. Oh, Mr. Mustafa. Oh, yeah. The next presenter is Mr. Dianta Mustafa Kamal. Yes, welcome. Yes, to come to.
This is different.
Different. Oh.
Yeah.
This is. Oh. Mr.
The others will come.
Oh. I mean, you are in this cluster.
Yeah.
Which title that you want to present?
Polytech.
intake conversation machine of plastic into. Yeah, please welcome to give the presentation. Oh yeah,
No.
just copy to this. Oh, using your computer?
No, sir.
Oh yes, just copy to this. Mr. Dianta Mustafa Kamal will present the Polytech conversion machine of plastic into oil filled with continuous system and reservoir replacing oil with 20 kg capacity. Please welcome.
Thank you for our opportunity to present my paper. I think this paper is my student, and they cannot visit here, and I am a substitute there. And then I will try to present this paper. Yeah. That is my background. Number of plastic waste in Depok and Indonesia is very large, and then the characteristic, then processing plastic waste, and the lack refuse machine. This is community needs analysis. Is done where is the special place for the processing of plastic waste in landfill. The 12 no, I think this is the issue, yeah. And then if yes, method are used in the processing of plastic is burning, like that. If there is plastic waste processing system which is more landfill needed, almost to reduce waste plastic, and then is it an effective method for processing plastic waste? There is no. Is there should be other ways to process plastic waste? Yes. The almost all the answer. Another problem is the effect of using this machine to the reduction amount of plastic waste in the epoxy landfill, and then measuring the power efficiency that produce the machine, and then the effect of using of this machine for the environment balance. The purpose, it is determine the effect of using this machine to reduction in amount of plastic waste in the epoxy landfill, and then knowing the power efficiency that produce machine, and then determine of the effect of using this machine for environmental balance, and then increasing the participation and the community ability to develop and use environmentally friendly technology. Introduction. The machine specification is powered by 3125 watt, yeah. Operating time 5 hours 30 minutes. Operating temperature 100 Celsius degree. Capacity 50 kilos. Performance 100 kilos. Plastic waste produced in 125 liter fuel. And then power efficiency is 44%. This is the component of the machines. And then reactor, and this is condenser, and this is the plastic waste input here. I will try how it works. This is the plastic waste in getting in the input chamber like that, and then the conveyor to push the plastic waste into the reactor, and then in the reactor we have the heater to heating the waste until 100 degree, and then the plastic waste can be saturated, and the saturated that plastic to be condensed in the condenser and become to be oil fuel. Yeah. Okay. The SWOT analysis. We know the strength of this machine is can reduce plastic waste in the Depok City as much as 1,500 kilogram per day, and has power efficiency 44%, and can produce oil as much as 125 liter in 5 hours 30 minutes. Safe for the users, the machine, and the environment. Calorific value, equivalent calorific value of the gasoline or premium in Indonesia in 45,042. The weakness is the residual waste of combustion process must be cleared manually. A continuous system of plastic waste insert is still manual, working with hand thrust. And then opportunity can reduce plastic waste in each landfill, can be used for 24 hours because it uses continuous system, can be used easily and safely, can be used for all types of plastics. Its use does not pollute the environment, and the lack of interest in the community to collect plastic waste to be processed into oil, because the paradigm of society still considers plastic sales to collector more profitable than recycled into oil. Is the trade. And then and then there's a presentation. Thank you.
Thank you. Thank you very much. Any question? Any question? Okay, Mr. Nizam.
Thank you. I think this is a good idea for equipment, but in my opinion, how about the oil contained in after condensation, have some oil, and then how about the oil specific in your production? It means similar like a premium or like ethanol, methanol, or other renewable fuel. About the exhaust from the burning the oil?
Basically, all the chemical value, like calorific value, we have done to compare the other Pertamax, premium, and the minyak tanah Indonesia, maybe. The oil, plastic oil, this fuel oil is higher calorific from minyak tanah, and then equivalent with premium, but still under Pertamax, under Pertamax. I see.
How about the exhaust gas from the burning?
Exhaust gas, we have no exhaust gas because the plastic waste is dioxin product. If we burn or we heating before under 400 Celsius degree, they can give dioxin gas. But in my machine, it's heating in 1000 Celsius degrees, and we can produce the gas. We cannot produce. We don't produce the gas. I think that's my answer.
Again.
I think it's a good.
I think you're interested. Maybe after this we can talk much more.
Okay,
Yeah.
it's okay because you still have time.
Okay.
So again, Ronaldo, how about the efficiency? Because you said you're burning with a 1,000 degrees Celsius. I think it's a need more fuel to burning.
The efficiency is 44%. Like this, 44%.
Yes.
We have estimate, or we have
I mean,
calculate.
thermal efficiency or the cost efficiency, or because I think for need 1,000 degrees Celsius, you need more fuel to burn the fuel.
This one,
Then,
this one, power.
Is about the power and other, what the efficiency is, thermal efficiency, is electrical efficiency, or
Oh, that's good. This is the thermal efficiency, like that. Because the electricity we use, and we compare the energy, the power, and the product 125 liter. We compare the power with the calorific value, and the output compare with input, that the power efficiency, like that. Yeah. Another, okay? Another question?
Okay, please.
Thank you for the opportunity.
Yeah.
I want to ask, what is your first step to separate plastic waste in Depok?
It's okay.
In Depok, as you know that there are so many people in Depok. How the way to give the socialization about this? How is your first step to spread plastic waste from the citizen? Thank you.
Okay. Thank you for the question. This is my threat, yeah, maybe because the lack of interest of the community to collect plastic in Depok, yeah. This is the threat for my research, because the paradigm of society still consider plastic sales to collector more profitable than recycle into oil, I think. And collector in Depok usually collect the plastic for to selling in the I think yeah, they're like that, kiloan in Indonesia, said all. And we don't, they don't interest to sell or to produce the oil or fuel. Like that. Thank you for it. Any question? Yes, any question?
Any other question? Mr. Rinza, do you still? Yes, this is very interesting because Mr. Mustafa can utilize the plastic, because in Taiwan plastic is not like in Indonesia. When we want to go to the market, we have to bring our own plastic. So, or if we want to get the plastic, we have to pay 1 or 2 until 3 NT the plastic. So it's very yeah, it's very different and very interesting. Thank you for the presentation, Mr. Mustafa. Effort to campus Artilis, AISCT as an alternative energy of bioethanol.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity that you given to me. Before I mention my presentation, I will introduce myself. I'm Oji Fahroji with my friend. My friend Handa Soliha Putrinul Ajija cannot visit here. And I'm just me with presentation about our impression. I'm from Department of Biology Education from Sultan International University, Banten, Indonesia. Well, in this question, I would like to presentation my report research with title fermentation, effectiveness of autonomous artists or breadfruit, extract as an alternative energy of bioethanol. Before I explain my research, I will describe I will tell my introduction why I research about this. This is nowadays carbon monoxide emission in the world has been increased and become a problem apart from energy security measures. Therefore, finding solution to global energy challenge become a concern, and now interest grow on the development of non-petroleum based sort of energy. As you know, Indonesia has abundant natural resources ranging from agriculture, mining, livestock, forestry, and etc. This aspect enable Indonesia to create a variety of products through various processing technology, both modern and traditional. One of Indonesia's natural resources is the plant abundance, which have many potential benefits for life. This is one of, as a tropical country, Indonesia is one of the Indonesian plants that has the benefit is a plant called breadfruit, Altacopus altilis. If in Bahasa is sukun, right? Yeah, yeah, sukun. Why I choose sukun I'm really interested with sukun or Altacopus altilis for breadfruit because sukun has many carbohydrates, yeah, and glucose. And then this is utilization of plant as a main source for production by ethanol in fermentation process by microorganisms. Ethanol, an alternative fuel as energy resource, has been a subject of great interest since the oil crisis. Potential plants to produce bioethanol is a plant that has a high sugar content and carbohydrates. Breadfruit has long been an important step of a primary component of traditional agroforestry system in Oceania. Where most forested are grown, the fruit can be cooked and eaten at all stages of maturity, is high in carbohydrate and is a good source of mineral and vitamins. This is breadfruit are protein value for 100 grams, 3.0 energy 100 KCl 130 kilojoule. This is breadfruit has carbohydrates 35% and extra. And vitamin C is so high caloric. And then, this is still a material when we mix bioethanol from breadfruit. Throughout the research steps, this is our tools when we research in laboratory, and then this is our material. Material eggs breadfruit at least and 5 liters of distilled water and 250 grams of sugar, H2S4.
and 50 gram of US fruit. And this is our method. Peeling and cutting breadfruits and weighing, smoothing or mixing and hydrolysis. And we separate for this treatment. Treatment of A, treatment of B, and treatment of G. And in different treatment, different also yes. Yeah. And after that, we can get we fermentation for 7 days and filtering or extraction and break distillation analysis, and we get the ethanol from breadfruit. Time for hydrolysis. The longer burning increase the color to reduce the compression of starch produced. Optimum time for hydrolysis for 60 minutes. And temperature of hydrolysis is 60 degrees Celsius. And time for fermentation is 7 days. After that we can filter or extraction and distillation to get the ethanol. Yeah, this is our conclusion. The best condition for fermentation is at a concentration of 11% by the time the starter ferments for 7 days. That's first the ethanol content. The ethanol is derived from the best condition are obtained as 5.501 or 2% to 38 on 68%. Thank you.
Any question? Mr. Isri, first. Miss Isri. Okay.
Thank you for the opportunity. I want to ask from the data we can see the content of the carbohydrate is high, and why why we don't use sukun to be maybe food resource. Okay, because as you know that in Indonesia, depend on the rice is so high, so we have to diversificate the rice to the another resource. Then why we have to use sukun to bioethanol to energy, and I think this material is competitive with human.
Yeah.
Thank you. I'm so sorry.
Thank you for your question, Ms. Ispi. Yeah, as we know, I find the diversification foods from the breadfruits, and but I want to know the bioethanol from breadfruits. I think breadfruits can have many potential besides as the derivatives as the what's the as like your question diversification of foods and the ones. And then I also even find the breadfruit can as a medical for heart disease or the others. But I think I want to try, and I want to know the breadfruit for bioethanol. Thank you. Yeah.
I think this is the good idea to use sukun as a energy. Yeah. But also we can also change our main food from rice to sukun. Yeah. As he said that sukun has many potential. I think in Taiwan has no sukun, right?
Yeah.
Yeah, because in Indonesia has many source. There is no in Taiwan like Melinjo, Sukun, all the other ones. Tas, yeah. Maybe you if you stay long here, you will.
Yes, I also for Nangka. Yeah.
For Nangka here?
In Thailand, yeah.
Oh, yeah, but I can't
And
find
also I
it.
found bote in Taiwan. You know bote?
Betul?
Where you come from?
Sebetulnya sih.
Jom.
Wah,
I ever heard about bote, but I don't know.
what is the favorite food from in Surabaya?
Okay.
Okay.
But it's interesting that we can found sukun or the other source that I don't think that there is no here, but there is one that found the sukun and nangka. Okay, next question, Mr.
I think same with Mr. If you want to make a good biofuel, please do not. You must prevent the food versus fuel problem. This is the main topic now. You must prevent the fuel versus food. If you make one good biofuel, one future.
Mr.
Miss.
No. Sorry. Before you raise your hand, if you want to ask question.
Me?
Yeah.
No.
Oh no. Before.
Okay.
Okay. No. Okay. Now,
Yeah,
Miss.
maybe everybody have the same problem. Maybe just for because this could be food competition. But I think I just want to let you know because maybe we have three raw material could be used for biofuel. The first one could be from wood. It is the first generation, but right now we cannot use it anymore. And the second from waste like lignocellulosic waste and the others. This is the second generation. And the third generation is come from microalgae. Maybe it's not so famous yet in Indonesia, but in here it's very famous already. And can I see your methods in the hydrolysis method? Hydrolysis. So you say in the temperature of hydrolysis, the greater of the temperature could be the greater of conversion. Is it true? Have you already tried? The greater of temperature, the second point could be the greater of conversion. Have you already tried? Because I think it could be break the contents.
This is
Yes.
I get from this. No, I get this is from the journal.
Oh, okay.
Yeah.
What kind of journal?
But
Yeah, you should show if you get from.
Yeah.
So show the source.
Okay, sorry for
Right. So what's the starter in the paper say? You use the starter for your fermentation, right?
Okay.
Starter. I think you
The
use
title.
some microorganism or the others. What the paper say? I see in the conclusion. Can you move to the conclusion? You use 11% by the time you starter ferment. So what is starter ferment? You use the one starter, right? In here.
yeah,
So what kind of starter did you use?
this starter.
I mean like microorganism, like maybe a small myces cerevisiae or the others.
Microorganism.
What kind? You also didn't find it in paper.
I'm not understanding.
Okay, that's fine. Maybe you didn't find it in your paper. You just tried to review this paper, right?
Yeah.
Okay. No. This before. Yeah.
You want to ask a question?
No.
Oh no. Okay.
Okay, thank
Thank
you.
you. Okay, this to you. And thank you. Please give applause.
Yes. Assalamualaikum warahmatullahi wabarakatuh. I would like to introduce myself. My name is Delmar Zakaria Firdaus. I'm all alone here, but this paper and all of the content we write it together with all of my friends Ari Permana Putra and Ginanjar Umi Pertiwi, but they are not coming to Taiwan because some problems, so I have to proceed with my presentation. And before I proceed with my presentation, I would like to give some disclaimer first that this presentation and paper is all based on literary studies. So I've never conducted an experiment with Bagas and Bacterium Clostridium thermosomal because the experiment using the sugarcane waste is a big business because it is very in a large amount. So we never conduct an experiment before. Okay, and we start from the problems. There are two problems here. The first, you can see that is the Angel Monument in Mexico City. The pollution that is caused by the industrialization and the number of vehicles that keep increasing these years have threatened us to the bed of health. So there is smoke surrounds this Angel Monument during a thermal inversion. Air pollution increased dramatically, and the Earth's surface, the circulation prevents pollution near Earth's surface from escaping. That's one of our problems today. The second one is the energy crisis. We have to know that the energy that we use now is from the fossil fuel. That is fossil fuel that we know these days are very closely related to the problem of energy crisis. Because fossil fuels are formed in and stored materials in the earth that comes from animals who were buried millions of years. So we cannot renew the fossil fuels because it have to be processed in millions of years. So we cannot renew the fossil fuel. We all know that in this picture from the Oil and Gas Journal, the deposit of gas in the world, we see that majority of the oil and gas were centered in the Middle East with 50 and 57% of all the deposit of oil in the world. In Asia and Oceania totally, including Indonesia, is only about 3%. It is very little amount of gas deposit and oil deposit in the world. And comes with the ideas. The ideas is using bioethanol as a substitution for the fossil fuel that we use these years, because bioethanol is one of the alternative fuels that have advantage than fossil fuels. Then why has to be bioethanol? Bioethanol, we process bioethanols from the plants, so as a raw material, so it doesn't make any accumulation of carbon in the atmosphere. Ethanol can also increase the efficiency of combustion because it contains 35 oxygen and environmental friendly, because some of gas emissions such as carbon monoxide, nitrogen oxides, and other gases are low. So logically, if we use like this, if it is the Earth surface, it is below the petroleum are below our surface. So if we use the bioethanol, the bioethanol processed with the raw materials from the plant, so it won't get any accumulation in the outside the Earth's surface, because it's on the carbon circulation, already in the carbon circulation. But if we use petroleum that deep inside the Earth, that we get into a little what is it? More accumulation of carbon from the under into the surface of the earth. And how we make it? How we make the bioethanol? Bioethanol, during this time, bioethanol was produced from molasses, sugar production, process waste, or starchy materials, cassava or corn. But we have another problem, that cassava, corn, and another materials that used in this day is a source of food. So we have to find another source of raw materials containing polysaccharides to process it to become bioethanols, but it is not used as a food source. It is to not conflict with the needs of the foods of humans. And here comes the bagasse. Bagasse is an industrial solid waste from sugarcane containing cellulose, fiber, and usually used as a raw material for the paper industry. Bagasse waste is not widely used. This waste is one of the energy source potential and generally is a cellulose material that can be converted into ethanol. The bagasse, until now, the potential of bagasse is very high. We can see this bagasse in numbers. There are 456,700 sugarcane planted area in Indonesia in hectares, spread on Sumatra, Java, Kalimantan, and Sulawesi. And there are 100 tons of bagasse can produce each hectares in a year. So total national potential of bagasse is about 45,670,000 tons in a year. That's high amount of waste, and until now it is not yet fully recognized to use it as a bioethanol in Indonesia. So normally the bioethanol production process contains three steps. The first step is pretreatment process. Pretreatment process used to break down the lignin structure and disrupt the crystalline structure of cellulose. We all know that we use the cellulose, not the molasses that contain in the bagasse. We know that cellulose is one of the polysaccharides, and we have to break down the lignin first to what is it? To get the cellulose from the bagasse. So first we have to pretreatment process, and then the second step is hydrolysis process to change cellulose into glucose, and the third step is fermentation process aimed to change glucose into bioethanol. The third step is very crucial because it is the step that forms bioethanol from glucose. But from the literature that we studied, there's a bacteria named Clostridium thermosalum that can make the second step and the third step of a normal bioethanol production process into one step only, called simultaneous saccharification and fermentation. So, if in normal process we have two hydrolysis and fermentation process in different steps, we only do the SSF process to do in one vessel, so the reaction vessel can be done in one step. So it's cheaper and shorter time to get the bioethanol from the bagasse that we use. And this is the same process of bioethanol production. We insert the bacterium Clostridium thermosalum and the prepared medium that we use bagasse in this case already meshed into the fermentation tank, and then we distillate it, purificate it, And then here comes the bioethanol. So the conclusion is, the first, we have to know that we face the two big problems using the fuel oil continually: the energy crisis and negative effect of environmental greenhouse effect. And then therefore needs of fuels alternative to solve this problem. We ought to know that the problem of alternative fuels that happen in Indonesia, because the alternative fuels is very expensive, because it has need a very high cost to process the bioethanol from the raw materials into the bioethanol itself. And besides that, the bacteria that we studied about Clostridium thermosolum can make the process of bioethanol production and process cheap and fast. And that's all about our presentation. And if you see the Manchester United logo in each of my side, that is because of my sponsors, Multistrada, the official tire of Manchester United Football Club. So maybe you get distracted. What is it about? Are you a fan of Manchester United? No, no, no. I'm not a big fan of Manchester United, but I have to show it because it is my sponsors. So thank you.
Thank you. I thought you are the big fan for the Manchester. Any question? Okay, please.
First, maybe I just want to know your reason why you choose Batas, not Restro, because we know together Indonesia should be the biggest rice producer in the world, right? Yes. So why you didn't choose Restro? Why you choose Batas as the raw material?
Because Bagas is one of my field study in agroindustrial technology, so we are familiar to Bagas. About the, what is it again? Restro. We never proceed with Restro, so we are more what is it? Familiar with the Bagas than the Restro, and because these facts of potential of Bagas is very what is it? Very high. So maybe from this paper is inspired any other people that see that we have a high potential of Bagas in Indonesia, which has not been used effectively in our country. That's all.
But in our country, Restro is much higher.
Yes.
In production. So
yes.
it's, okay, you cannot use this reason. Maybe the first reason is to be correct, and the second question is you mentioned about SSI, right?
Yes.
Actually, in application, it's not really easy to operate because we have to mix both hydrolysis strain and fermentation strain together. So did you use the Clostridium thermosolum for both process, for fermentation, also for hydrolysis?
Yes, in one vessel.
So this kind of strain could hydrolysis cellulose and also could produce bioethanol from glucose.
Yes. Well, yes, it is from our brainstorming with the other people that interested in Bagas. They are also asking about how come you do the simultaneous saccharification and fermentation in such an easy sentences?
Because in my previous study, I also used Clostridium ECW1, but it just can make process the hydrolysis, the second step, and the first step, but not for the second step. The second step, we have to use the other strains. The other strain
rather than Clostridium
thermosolum. Yes, not Clostridium thermosolum, because it just can consume cellulose become glucose. Clostridium thermosolum cannot convert glucose to bioethanol in my study, but I'm not sure about your strain.
Okay.
That's what I want to make sure. Okay.
So in your study, how you make bioethanol from the?
I use two. I I can use these like PK activities. I also can use like micro battery like Zemomanas mobilis, or maybe also we have the other like Clostridium, Cl2, Cl4, and the others.
Okay.
But for this, as my knowledge, this strain only can convert cellulose to glucose, cannot
Okay.
convert glucose to bioethanol.
Okay, thank you, ma'am. Another critics or question?
I think that is up. Thank you. You can continue to discuss with Ms. Mahayana. Yes, interesting topic between two of you. Yeah. Okay.
Everybody, my name is Dikveri Firdaus from Material Science and Engineering Research Society of Metallurgy and Materials Engineering Department, Universitas Indonesia. I'm also with two of my friends but cannot attend this conference, so I be the one that present this to all of you. My professor is Professor Anna and Professor Herman is the Professor of Nanomaterials and Composite. My research is actually a literature study, but we are already under progress work. So actually, this work is under progress. So because it is still under progress, we consider it as a literature study. The title is literature study of surface plasmon resonance or SPR effect of 100 nanometers spherical CU or copper nanoparticle, the enhancement of silicon thin film solar cell. This is the introduction because this conference theme is about entrepreneurship, so I want to match my research to the demand of the market. So actually this is the chart of the China Swift solar photovoltaic market. It's actually increasing for 2008, 2010, it's like a significantly increase. The market share is near 1% and it's about 5 gigawatt in 2008 and expected to rise to 20 gigawatt by 2015. So it's like the market demand is high, so it's like the potential for us to make a technopreneurship, because if we photovoltaic devices now demand of the market needs to develop a thin film. It's like cheaper photovoltaic but high efficiency. So we are going to talk about that. And because of the increase, so I say that the photovoltaic also increase the requester of the efficiency. So we would like to make a cheap material but also have high efficiency. This is actually the theory of the basic theory of photovoltaic devices. The photovoltaic devices actually requires three basic attributes. The first is the absorption of light in the material. This is actually the third generation photovoltaic device, the thin film of silicon, and we can see that the sun energy goes to the film. After that, it will the energy will excite the electrons to go to here. So this is actually one neutral area. After the sun hit these, and the electron will move up and the hole will move down. So it will make different potential. This will be positive and this will be negative. So if you have light here, there will be electricity happening there. So it is like the basic of the photovoltaic devices. The first is absorption of light, and the second is the separation of charge carrier. The separation, the negative will go up and the positive will go down. And the last is the separation extraction of the carrier. So it will separate and meet at the p-n junction at the middle of the film. This is actually the Shockley-Queisserling. It's like the limitation. Why? That it is the limitation tell us why the photovoltaic cannot reach its 100% of efficiency. The first is because of the blackbody radiation. We know that material have its ability to absorb heat or energy, but it has limitation how much energy it will absorb. So for silicon, there's about 3,000 Kelvin, something like that. And if the heat exceeds those limits, it will not be absorbed by the material. So it will be lost. So it will be somewhat one of the limitations that consider of 7% of the reducing efficiency of photovoltaic devices. The second is recombination. I've already stated before that the energy goes here, the neutral, and after that the electron will go up and the positive will go down, or it's like up to you if you design it. But if you have thick solar cell, the electron cannot go up there. If you want to go up there, it needs much energy. So the thing is, we have to make it much more thin. So it's have one little small energy to go up there. So if you don't have much energy and you have a thick film, so it will be hard for the electron to move. It needs much more energy. So it's the recombination. And third is spectrum losses. It's like if the energy given by the sun exceeds of the band gap, it will lose. So we can see here if the band gap is 2 of the silicon amorphous, and the percent of light energy is about 50, it will be low band gap photon, so it will be lost. So this is the area that can be used, but this area is lost. So it's like the spectrum loss. So altogether, the body, recombination, and spectrum losses, all of it will reduce the efficiency for about 50%. And the last is Landsberg-Baruch re-emission. So it's like the re-emission, because of all of these, the energy will be emitted back to the environment. So it will not be absorbed, or something like that. So we have to consider how to make thin film solar cell, but with the consideration that we have to make it thin so that the recombination will not happen. But if thin, the carrier collection length will be very small. So it's like opposing thing, but the thing is we have to design material that is thin but have high efficiency. This is actually the introduction of surface plasma resonance. It's like a nanoparticle, which like gold nanoparticle, can propagate the energy. So if you put here, the energy received by the heat will propagate here. So it will not re-emit back, something like this too. The energy come here, it will be trapped here, because if the energy want to come back, it will be collide here and come back again. Something like that, something like this too. If the energy comes, it will propagate, so it will not come back. So it's like the strategy for us by using surface plasma resonance to increase the efficiency. But the surface plasma resonance, the last research is using gold nanoparticle, which is very expensive. So the thing is, we are going to sell to market. The market don't want expensive things, so we are searching for cheaper materials such as copper nanoparticle. The fabrication is quite simple. We use the wafer of silicon. After that, why we use silicon thin film? Because it's low cost, cheap, and also after we obtain the crystalline silicon, we use it anneal step. After we using the chemical vapor deposition first for make the wafer. After that, we anneal it to make it polycrystalline. Because the polycrystalline will contribute to the cost saving and stability and durability, because the polycrystalline silicon have a size of 1 to 2 micrometers. So it will small material but have a high durability. So why we use those? Because it's like cheap but have high properties. This is how to make the thing before is to make the silicon wafer. The next is how to make the copper nanoparticle. The first we use poly and phenyl pyrrolidone, we dissolve it by DEG, and after that we use reducing agent such as phosphenate monohydrate, and also we inject the copper sulfate. After that, after the synthesis, all of the synthesis, it will have the particle size for about 45 nanometers. But it's like monodispersed, because we can see here, but if we use sulfate, we can have low polydispersity, or it means monodispersed. So it's about 100 nanometers and 100 nanometers, and it's like the range is 100 to 150. So the range is not so far. But if you use chloride, the result will be 100 to 200. So it's like far. But we want to use 100, so we use this to have the monodispersed of 100 nanometers. After we made it, we use it to the nanolithography process. So we put all of the copper nanoparticle here. After that, we use the PECVD again to make wafer up here. So it's like a burger, like silicon, copper nanoparticle, and then silicon again, something like that. This is the result. I say the pre-result because it's still under progress work. But the thing that we can see here, we use the three equation here. to calculate how can the copper nanoparticle contribute to the increase of the surface plasma resonance effect. We use here that the wavelength provided by the sun reflectance is very small, something like here. But before I don't put the before chart, but the before it's like higher, something like this. So the thing is, by we use the copper nanoparticle, it will be decreasing the reflectance. So of course it will increase the efficiency itself. Also, we don't use 1 nanometers only, but we don't contribute to the size, but we also use the shape of the nanoparticle. Here, because of the research of Professor Atwater at the Caltech, Pasadena, we say that this, the shape of nanoparticle contribute to the efficiency of surface plasma resonance. Here, we can get this graph so that the sphere, sphere here, 100 meters can contribute to the maximum path length for about 10. So it like the size and the shape is have the effect for the surface plasma resonance. So not only the size but also the shape. So we use both of them to increase the efficiency of the source cell. So my conclusion is, after all of I provide the information. So the thing is the injection of copper nanoparticle inside of the polycrystalline silicon photovoltaic devices will increase the efficiency of the photovoltaic cell. But actually we are now in under progress work, so we need more study and more literature for make ready to commercialization of these material, because we can see the first slide that this very rapid increase of market demand. So it will be the potential of technopreneurship. So we will search for this to make high to make high market demand, so we can sell it to the market and we will have much money from that. So I think it's very potential. So thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Presentation. Any suggestion? Any comment or question? Yeah,
thank you. I think it's a good presentation for you. You always said about the efficiency, and I want to know how much the efficiency in this. Because I think photovoltaic is a dead technology for now. Or if we compare with the others, electrical producing. And photovoltaic is a dead technology or current technology.
Yes, actually, there is so much technology that related to photovoltaic devices. I use one of it, like surface plasma resonance, because there is the first generation, the second, and I use the third generation of photovoltaic devices. And for my research, I have the efficiency increase for about 18 to 20% for 54 6 nanoparticle each for something like if they have oh yes, if I have here these nanoparticle have its length, the length we use in micrometers, and this nanoparticle to this nanoparticle we have the length. The length we provide is about 54 plus minus 6 nanometers each of the particles. So if we use this, we will get the efficiency for about 18 to 20% of the efficiency. But I don't know if we use another length, but this length is provided by the research of Professor Atwater in the California Institute of Technology. So we use something.
Okay. You consider about the Brown motion in the nanoparticle, you know? Every nanoparticle you put in some media have a Brown motion. And also you consider about this because the nanoparticle cannot stay in the same position. How about if he have a Brown motion in their medium?
Yes, actually I already think about that too, but I have this in nanolithography process. I use the additive material here, that is one of the additive of the copper. We use copper sulfate here, so that the silicon can maintain the position of the nanoparticle. So we use additive, so it can move. But if we use gold nanoparticle, it will not move, but it's like very expensive. So we use copper, but we have to use more additive. But it's not so expensive, so it's like much more good for the market demand.
Any question? Okay.
Thank you. I want to ask about the price of you said the cheaper. How price the thin film you product?
The thin film I produce is I use the polycrystalline.
Estimate price.
We use a crystalline silicon thin film, and then we use it by annealing to polycrystalline. So we don't buy it by polycrystalline, but we make the polycrystalline. So it's about how much in US dollar? It's about
In Indonesia.
it's like 2 juta rupiah each of centimeters. It's like 1 centimeters. It's like here. But it's a high efficiency than the other, like DSSG or dye sensitized solar cell. The efficiency is much more lower, but it's much more cheaper. So we have to consider where we want to use this material for certain use. So we don't want to use this for maybe for a lamp or for the house, but we can use this maybe for military things, or maybe such as spy plane. We can use this because it's very small and very thin, and it's not the mass is very also low, so it will be very useful for airplane things.
For what electricity? The electricity we can produce.
We can produce all electricity. So the concept here is
The power.
we can use all of the arus. The thing is, we can use all of the flow of the electricity, we can use everything, but the thing is we use here. So if you want to use cable or something, it's up to you. But the thing is, we use this for produce electricity, in form.
What power? I think what the power in electricity in what cell, or I don't know.
Actually, it's a kind of different because in every place we have we know what there is AM 1.5. It's like the air mass. So if we use the standard of the air mass of 1.5, we can have the voltage that's different, also different with every humidity, and it have different. But actually, the efficiency will be here. So it's considerable the heat of the area. If the area have the heat watt, we can calculate by using this percentage, so we will get the result.
Oh, I see. How long you can produce this your PV film?
Actually, now I'm still working by buying some materials, but I don't work now because it's like under progress work. But I estimate it will be I will have the result after 1 year because it needs so much money to have a prototype. But after prototype, we can produce it much more low money because people already know something like that. But if you want to make prototype, it's much more expensive.
In my equipment, we need 100 watt. We need what thin film. How bigger? How big? Maybe you can estimate your thin film.
Each the price,
The size.
the size. Each cell, we call it a cell. Each cell we have it 1 centimeters. 1 centimeters. It's one cell. It's one cell of the photovoltaic. Only one cell and one layer. It will be here.
Only that, yeah.
Yeah.
Or not big.
Not also big. If you want to make big, so you have to combine one, and it's very expensive. But I have high capacity.
Museum.
Yes.
Also,
But here we have very high, 18 to 20, because the last research we only obtained for the SSC is only about 15, 16, 14. So it's like it's in the 3rd generation of photovoltaic. But conventional it may be higher, but it's much more expensive, much more, and to 2 juta rupiah it's much more expensive. It's conventional.
Any question?
Because I do very interesting in this research.
I suggest you make sure that the nanoparticle is not moved. This is the difficult thing in the nanoparticle work. Make sure that the nanoparticle is not moved. But this is a problem. If you make a moving, the light will be discarded.
Yeah.
Make sure that it's not moved for you.
Thank you.
Okay. Actually, this is also interesting for me. So I want to ask one question. You before the earlier you said that you synthesize the nanoparticle, right? So what kind of characterization that you use here?
Yeah. For measure about I use this polyol method here, and because we don't actually characterize each of the nanoparticle, but we are searching about the size of it. So the size is about 45 to plus minus 8 nanometers. So this is 45, and after I agglomerate it, and we obtain 100 nanometers of nanoparticle, and it is actually monodispersed, so we can get it at the solution, we can get it to the nanolithography process. But if we use this chloride, it is polydispersed. So the result will be 100 nanometers, 200, 300, and it will be very hard for us to search about the 100 nanometers. Which one is the 100 nanometers?
So you didn't use the measurement device like TM or SEM
I will use
about the characterization, because this is in nanoparticle, right? So you need to measure. You need to make sure about the size. So what kind of
characterization I use is XRD to produce. The thing is the produce of the nanoparticle is made by crystal of FCC, of phase center cubic, and have size of this.
I think for the XRD is to know the structure. But for the size?
The size, we can use a TM and choose SEM, but actually it's much more better we use the high definition of SEM, because the TM is much more expensive.
Yes. So you use SEM here?
Yes, because 100 meters is possible to use SEM, but 100 we can use TM.
Actually, your research also very correlated with my lab, because my lab is about the nanoelectrochemistry. Maybe if you want to continue to the higher degree, maybe I can correlate you with my professor. You also give a great progress. You also consider about the market demand, so I think it's very great.
Thank you very much.
Thank you very much for Mr. Dick Fredeno for the presentation. This is the last presenter here. So I think it's enough for us. That's all. Then after that, we can close this section and then we can take pictures together. Okay. Assalamualaikum warahmatullahi wabarakatuh.